In this video, we learn how to construct a confidence interval for means. The basic idea is that we're going to use sample data to construct an interval estimate for the population mean. For example, the ages at which a random sample of 35 mothers is shown on the table below. Construct a 95% confidence interval for the average age of mothers at the birth of their first child. To do this, we're going to use the confidence interval presented in the course notes and in the textbook. So we start off by computing a numerical summary. We can easily see that the sample size is n is equal to 35, and we can use StatCrunch to compute the mean and the standard deviation of the mother's ages. So we would open up StatCrunch, open the mother's ages data set, and then go to Stat, Summary Stat, Columns. Click on the mother's ages, and then select the statistics that we want to compute, the sample size, and then I'll hold down the control button, the mean, and the standard deviation. And just a quick reminder, when you hold down the control button, you can select the statistics that you want to compute. Otherwise, just hit the compute button. So now we can see that the sample mean is 22.25714 and that the sample standard deviation is 5.62213. Our next step is to compute T sub C. So T sub C is a multiplier. It is the number of standard errors needed to achieve a confidence level C. If you go back to earlier in the semester, we talked about the 68, 95, 99.7 rule. And if you want to include the middle 95% of your data, then you would need to go 2 standard deviations in either direction. So the sample mean minus 2 standard deviations and the sample mean plus 2 standard deviations. So we have good reason to expect that the value of T sub C is going to be a number close to 2. To compute the exact value, we use a student t-distribution with n minus 1 degrees of freedom. In this case, the sample size n is 35. If we subtract 1, that will be 34. So we're going to use a student t-distribution with 34 degrees of freedom. The student t-distribution is a bell-shaped symmetric curve that looks a lot like the normal distribution. It is centered at 0. And in this case, we want a 95% confidence level. So we're going to have 95% of the area in the middle to represent the middle 95% of samples. And that leaves a total of 5% for the tails. If I divide this by 2, it's an area of 2.5% or 0.025 in each tail. So T sub C is the number that separates the middle 95% from the right tail. By symmetry, negative T sub C would be the number that separates the left tail from the middle 95%. To calculate T sub C, we need to use the t-distribution calculator. You can find this in StatCrunch. If you go to Stat, Calculators, T. We would enter our degrees of freedom, which in this case is 34. Enter the area of the right tail, 0.025. Should switch this to a greater than or equal to. Press compute, and T sub C comes out to be 2.03224. So now that we have the value of T sub C, we can compute the margin of error. We use the letter E to represent the margin of error, and it's computed using T sub C times the sample standard deviation divided by the square root of n. In this case, 2.03224 times the sample standard deviation of 5.62213 divided by the square root of the sample size, which is 35. Enter this into a calculator, and then we would find that the margin of error is 1.93126. And now we are ready to compute the confidence interval. To compute the confidence interval, take the sample mean and add or subtract the margin of error. So the sample mean will be the center of our confidence interval, and it is 22.25714. And then we add and subtract the margin of error, 1.93126. If we do the subtraction, it comes out to be 20.235. If we perform the addition, it is 24.188. So then this is the confidence interval for the average age at which mothers have their first child. We would expect that the true average or the true mean is somewhere between 20.23 and 24.18. We don't know for sure whether or not the true age lies within this interval, but we have 95% confidence in the methods used to produce this confidence interval.